Yeah, thank you very much. Short about me. Yeah, I'm a PhD student at the Institute for Application Security in TU Braunschweig or Brunswick, like right in the middle of Germany. I do like all things security and privacy. I think we all do. I'd like to play some CTF in my spare time with our local Brunswick team, Cyber Task Force Zero. I try to help a bit with our local NGO for the GDPR rights, datarequest.org. This is about phones. Everything I do through my phone. Like the trip here to Toronto, my daily life, everything is driven through my phone. So my phone basically knows everything about me. But it's not really my phone that knows everything about me, but the applications in my phone, right? And they know a whole lot about me. And these applications have to make some form of revenue. They want to make money. I mean, sure, there are some open source applications. Sure, there are some premium model subscription applications. But most of the applications try to sell your data or try to show you advertisements. And they do this by tracking. So they try to profile you as a user. Hey, this user likes to use this application and likes to use this other application. And they maybe even like this thing or this thing. And they take this data to show you personalized advertisements. Or just sell your user data directly. And this talks not only about phones, but about tracking in mobile applications. And we assume that people or app developers don't build tracking or advertisements themselves. They use some form of third-party provider. So an advertisement library, an advertisement provider, an advertisement SDK. And they will include that in their application to show you advertisements or to just track you. And this is my threat model, so to say, for this talk. Like, we have this tracking provider in our application, our privacy attacker, as I like to call them sometimes, who's trying to get as much data as possible about the user. And I will be running with a fictional example of something I call ad.com, because it's just a short name, so don't worry if that's a real company. By default, if I'm, for example, this web gaming application on my phone, and I will try to get more information about my user. For example, what kind of news are they reading? What are they doing in the news application, so the blue application? By default, they cannot simply do this. I mean, on desktop, you can basically do anything without any fancy sandbox rules, but the mobile ecosystem is pretty locked down. So on Android, for example, we have this application sandbox where Android takes the measures to sandbox applications from each other, so you cannot just read arbitrary data and get arbitrary information from other applications. And if you want to do this, if you want to link users as a tracking provider across applications, you have to resort to something called an ad ID. So on Android, this is called for example, the Google ad ID, or we have something similar on iOS, which is called the identifier for advertisers, the IDFA. And if I, as an application, or as a tracking provider, I want to track you as a user across applications, my tracking SDK can fetch this ad ID, and then it gets the same ID for the same user. So we have this unique ID identifying this specific user, and the system provides this API, which provides this ad ID. But the user can reset this identifier, or even delete this identifier. So if I resort to, for example, in iOS, I tap on the I don't want this app to track me button, or on Google, I can just delete my Google ad ID, the system API will return zeros. So for me as an attacker, as this privacy attacker who wants to track the user, this is bad, because I want to be able to track the user across all applications, and I don't want to be stopped by the user. So I could resort to, for example, fingerprinting. We know this from the web, for example. We can try to get as many information and data points about the user as we can get, or about his device, for example, software versions, or supported APIs, or the screen dimensions, or like hardware timings. How long does it take to compute something? How long does it take to render something on the GPU? And we can use these to build a fingerprint. And we know that this works. But fingerprints are a bit volatile. So for example, the user might plug the device in, and now the CPU is faster. Or the user might make a software update, and now the fingerprint changes. So as a tracking provider, I can't really rely on fingerprinting either, because fingerprints tend to change over time. So what I'm going to talk about today is a new tracking technique, which beats these challenges. And we call this new tracking technique HyTrack. And we found this in the lab. We came up with this, and we've looked at the capabilities of this new tracking technique. And I will discuss these capabilities today with you. And then we'll talk about what you can do against it, because we don't like this privacy attacker. But first, we need a bit of background to understand the attack. So if, as an application, you want to show web content on Android, you have basically 4 ways to do so. We have just opening the user's browser. So on Android, this is called in technical terms, you can send an action view intent, which tells the system, hey, we want to view this content. And this will launch the the default browser of the user. So they will be taken outside of the application into their default browser, and the page will load. You just click on the link, so to say. As a second way, you can use something called a web view. And if you are into Android development, you probably have seen them or used them before. They're like a mini browser which can be put inside of your application as a component of the application, and it will render web content. But it's like not really a full browser. So you don't have all the nice browser features, or maybe not all the modern APIs, and it has a history of security issues. So we don't really want to use that either. So for a while now, I think 5 years or something, we have a new thing. It's called custom tabs. It's a bit like the first option, we just launched the browser. But the trick is that we open a special browser tab inside of our application. And the neat thing is that this browser tab shares the state with the regular browser of the user. And they are called custom tabs because apparently you can customize the URL bar a bit. But this is not the interesting part. The interesting part is that, for example, users are already logged in to whatever web page you're opening. Because if they're logged into this web page in their default browser, they will be logged into this web page in this custom tab. Not, for example, with the web views, where you just have your own little browser inside the application, and the user would have to log in again, which is not convenient. And there's also no context switch for the user, because this custom tab is rendered inside of your application as an activity in your application, and they are still in your application. So if they press the back button, they will just be in your application again, and they don't open a whole nother app. And you get all the nice browser features. So all the modern browser features are there, because this custom tab is hosted by the browser, but included in your application. And this looks a bit like this. So if you are using an Android phone yourself, you will have encountered these before. For example, if I tap on a link in Gmail, this will open. And as you can see, the Google Help page shows my avatar, like this tree is my avatar. And it can do so because this is the shared browser state. So I'm logged into Google in my main browser, Chrome in this case, and this custom tab will have this shared data. I'm logged into Google, it can render my avatar. And this enables fancy features like login with. This example, login with Facebook. Your application can show a login with button, and I can tap on that button, I will be taken to Facebook and just confirm, yeah, I want to log into this application as John Doe in this case. Please continue. And I don't have to log into Facebook because the shared browser state establishes the shared cookie jar, and I'm already logged in. And I don't have to identify and do the login process all over again. So this is pretty convenient for users. And as a fourth way, we basically have upgraded custom tabs. They're called trusted web activities. They are basically full screen versions of the custom tabs we have seen before. And they are still hosted by the default browser. We still have this shared browser state, but they require a so-called verified digital asset link between the application and the website. And this link basically allows the browser to verify, hey, this app really belongs to this website, and this website really belongs to this app. And this is verified by the browser, so you can check it in the Chrome code, for example. And on the web, you would host a file in your well-known folder, which is like this folder in your web root, where you put all the well-known files. And in the application, you can specify a website in, for example, your manifest, or you could add applications at runtime, websites. And they look a bit like this. you have this JSON payload where in the app, for example, you specify, hey, I can handle links to on the web example.org. And there's this permission system, but we only want to talk about this one permission. I think only this one is spec'd. On the web application side, you would host this JSON blob, which says, hey, as a namespace, the Android app, in this case with an Android app ID from org.example.app, can handle links to me. And this is supplied with a fingerprint. So the fingerprint of the keys used to sign the application are also provided. So now the browser can really verify that the application and the website belong to each other. And after we've established this, we can show our web content in a full screen trusted web activity. And this whole process is not only used for this, but also for other application features. For example, if you want to be able to open links in your application for regular browser activities. And the core idea of this new tracking technique, HyTrack, is that we use this shared browser state between custom tabs or TVAs and the default browser to share tracking data. And we can do this across applications, and we basically could put any tracking data there. For example, hey, you like this event in your application, you like this thing, or we can just use it to exchange tracking IDs and then do the actual tracking in another channel. So this is the core idea. As an example, and here we come to my one example of ad.com, we, as an app A, this gaming application, we could open a custom tab to ad.com. And ad.com could then go ahead and set a cookie containing a tracking ID. And app B can now open a custom tab as well to ad.com, and the browser will send that cookie to ad.com because we have the shared browser state, the cookie is in the cookie jar of the shared state, it's for ad.com, so it will be sent along. And ad.com can now see that the same user is using app A and app B. So we use this shared browser state, the shared cookie jar across custom tabs, across applications to track you or to track users across applications. And we can use this to share anything, but in this example, we're using it to share IDs. And to drive that example home, as a flowchart example, app A opens a custom tag for /track, for example, on ad.com. And the custom tab, the browser, will request that resource from ad.com. Ad.com will assign the cookie, in this case, some string containing a tracking ID. And on the second request from app B to ad.com as well, this cookie will be sent alongside, and now ad.com, or HyTrack as we call this process, will be able to link both applications to the same user without relying on the existing techniques. So we can cross this communication barrier, the sandbox, so to say, with this shared browser state. We can track users reliably across applications without using the existing approaches like the Google Ad ID or fingerprinting. And we do this with this tracking cookie inside of our browser state. But the nice part, or the scary part, is not only applications could access the tracking data, but also regular web tracking can access that cookie jar, right? So we are not only linking users between applications and between different tracking events in these applications, but also in the regular web tracking behavior. So we can link things, users across applications and the web. But there are some remaining open points. As a privacy attacker, there are some points I want to fix at this point. So this is quite obvious, for example. We have seen this custom tab example with the large URL bar on top, and the user will notice if we just open browser tab after browser tab after browser tab. And we haven't discussed also how can we get the user back from the web content to the actual Android application, because there is no API call for that. So let's talk about the first point, the obvious thing. Instead of using custom tabs, we can rely on these full screen custom tabs, these trusted web activities. So since they are full screen, we can just style them as we want. So we can just, for example, make them look like some application part or some full screen application which is used to be, which can be look different. For example, you would implement a loading screen in the website. So you take the user from your application to this fake loading screen, or maybe even a real loading screen, back to your application. Or you can just use some framework which makes it easy for you to just style web content like the Android native content. And you can use this to style the full screen, style the TVA in the full screen mode as you want, and it will be seamless to the user. I'm not an artist or anything. So on the left, we have like this demo application in material design on Android. And on the right, we have some demo application in material design on the web. And my point is here, I'm not a designer or anything, but we can use these existing frameworks to style applications that they will look the same. So as a user, I won't be able to notice that the right thing is web content and the left thing is Android content. So we can use these full screen capabilities to hide the transition between native Android content, native Android land, and the web content. Okay, we have figured this out. It's not as obvious anymore. But how do we get the user back from this web content to our native Android application? And we can use another cool Android feature for this. As an app, you can register something called intent filters. You can listen for certain things. So you can tell the system, hey, I'm able to handle this and that link. Or, more specifically, I'm able to handle this URL scheme, this protocol, which is handy if you have like an application, I don't know, some gaming application which has its own scheme, it will be able to just launch if you press on the link in your browser. But if you register a custom and unique scheme for our application, we can use that to guide the user back from the web content to our application. And because we use a custom and unique scheme, the Android system will see that only our application is able to handle this link. And so it must start our app again. So clicking on a link will take us back. So we have like a one-click privacy attack, so to say. And the resulting user experience, user attack, something like this. We have this native Android application, whatever, and at some point it decides to track the user, so send some tracking data home. And we'll do so by opening this TVA, which will request in the background add.com, and will send that tracking data alongside to add.com with the tracking cookie. And we use this full screen to show some content, in this case, like an advertisement. And the users may be used to advertisements in annoying Android applications, so they just click on back or close ad or whatever, and this will trigger a navigation, telling the Android system, hey, I want to open this custom unique URL scheme. And the Android system will check which application can handle this specific scheme, and because it's unique, only our application will pop up. So we take the user from this Android native land to the web content, tracking them, and then tapping on a button back to the native Android land. So we talked about the mechanics and how the tracking works, how we can link users across applications. But we call this HyTrack. And this is maybe obviously, maybe not, inspired by the legend of the Hydra, like this mythical beast, where if you like slay one head, another one will regrow. And HyTrack is a little bit like this. So, for example, you might be a privacy-conscious user, and you might, I don't know, clear your browser storage once a week or something. But HyTrack will be able to restore. If you slay the cookie jar, another cookie will just regrow, or another head. Maybe you want to reset the application to get rid of the tracking, but HyTrack can also be dead and will be able to regrow a cookie. Maybe you even decide to delete the application and install it again, or maybe wipe your phone and restore a backup or something, and the tracking cookie will reappear again. That's why we call this the Hydra effect and call it HyTrack. And this works because on this navigation from the native Android land to the web content, we can exchange data in the URL. Because we're using, on launching the application, a URL, we can just pass arbitrary data in the URL, just in some query parameter or something. And then the navigation back, we only need this fixed constant of the unique scheme. We can just pass arbitrary data on this navigation back as well. So we have this direct communication channel between the native application and the web content. And we can use that to sync this cookie jar. So for example, we've established this tracking cookie in the cookie.gen@.com. And when we take the user back to the application, we can just put that cookie in that request. So now the application can also store that cookie inside the application storage somewhere. For example, in Android, this is called the shared preferences. And if then the user decides to, hey, I'm going to clear my browser storage, I'm a privacy-conscious user, at the next tracking event, we can just go ahead and send that cookie data alongside the tracking request. And now the web server can see, hey, we already know this user. They try to get rid of their cookies. We can just reinstate these cookies from this shared state from the application. And we can use a handy feature from the Android system, like this automatic backup systems by Android, by Google, will just be so nice and back up certain parts of the application. And they will be restored, for example, if you reinstall a previously installed application. Or if you decide to get a new phone or wipe your old phone and log in with your account, they will be able to restore these application data. And if you just put our tracking data there, HyTrack, or this tracking attack, will be able to persist across app reinstalls, or even like wiping a device or getting a new phone. So what can we do against this? How can we be like Hercules? How can we slay this beast of HyTrack? Like, the obvious solution would be, or not so obvious, a bit cumbersome, would be to clear the browser storage, to remove all applications, and then reinstall them all if I still want to use them without backup. So this is a pretty scary situation. We have this like pretty powerful privacy attack, and I'm a scientist after all. And we wondered, are people already doing this? So we did some studies. And we will talk about these right now. First, we wanted to check, is this feasible across devices? So if you're familiar with Android, you know that every Android vendor ships their own version of Android. So for example, I have a Samsung, and that Android version is slightly different than the stock Android version. So we tested this attack across a range of different Android flavors and all of their default browsers. So we got a whole lot of devices, like a Google Pixel, a Samsung, a Huawei, a Xiaomi, Poco, and a OnePlus. And we also tested like this custom ROM Gofino S, which is known like for security and privacy hardening. And besides all of the browsers coming with these devices, they're stock browsers, we also tested various non-stock browsers. So additionally, we tested Chrome, Opera, Firefox, Tor browser, UC, and Brave. And we found that all the Chromium-based browsers are vulnerable to this attack, to this tracking technique. So Chrome, Vanadium, like the default browser of Gofino S, Brave, and Samsung. And the Firefox-based browsers are affected, Firefox and Tor. And these are all browsers that support custom tabs. The other browsers that are not affected just don't support the feature. So every implementation we know of is affected. And yeah, we observed some quirks. For example, they are hosted, these custom tabs and TVAs, by the default browser of the user. And for example, if an application requests a trusted web activity, but you are, for example, using Firefox, which doesn't support trusted web activities, the system will fall back to Chrome. And the funny thing is that Google required people to ship a Chrome alongside the applications if you want to ship an Android ROM. So basically everybody has a Chromium available and installed. So if you request a TVA, you most certainly will get a Chrome and will get a TVA. And we observed that if you try to disable Chrome, your browser will fall back to CTs. So if I have Firefox and disabled Chrome, I will just get a custom tab if the system requires a TVA. And we found that only Chrome and Vanadium are informing users about the CT and TVAs being rendered in the first place. And we also noticed that even the TVA is full screen, this will still leave traces in the browser history. So if you check the browser history after a successful attack, you can still see the traces of this attack. So we know that basically every browsers affected. So we wondered, is this just some crazy idea we came up in the lab with? Is somebody already doing this? Because we just came up with this idea and we wondered, is anybody already doing this? And to answer this question, we pulled a whole lot of applications from the Google Play Store. So we pulled about 4,400 applications from the Google Play Store, like in June last year. And we did this by scraping the top 200 lists by the 32 categories offered by the Play Store, collecting a list, and then getting all the APKs from Google. And we then did several studies. We did a dynamic app analysis study, and we call this one like a no-touch traffic analysis. So we take a real device, launch an application, and look at the network traffic. And the idea is that if we continue opening applications one after another, and there would be HyTrack in the wild, we would observe that in the network traffic. So we don't reset the phones between applications and just launch one application after another without interacting with them. That's why we call it a no-touch analysis. And we can just search for these cookie values, these shared tracking IDs in the network traffic. And we let these applications run for 60 seconds. And we did this with a setup we established in previous work, where we have like this machine in the middle setup with a great midterm proxy. And we use some FRIDA and objection to get rid of TLS certificates so we can see the encrypted traffic and get rid of TLS pinning. And we did this on a Google Pixel because they're easy to root in a lab Wi-Fi and with a lab computer just installing and launching the applications of the application. And on average, we have seen 35 requests per application. So without the application, and just launching the application, waiting a minute, and killing the application, we see about 35 requests per application. And we observed about 45,000 cookies being sent, about 10,000 cookies being received. And we then filtered these cookies. So we've searched for values that are shared across applications, because we are searching for these shared tracking identifiers. And we filtered for cookies on the same domain, because only then the attack works, because we assume that we have this one first-party tracking cookie, my example at.com. And we searched for cookies set by browsers with the right, or by HTTP clients with the right user agent. So because we want to see this attack done through a CT or TVA, we can search for the right browser user agent, which was responsible for CTs and TVAs on our test device. And then we filtered manually for applications that actually show a CT or TVA at launch, because only then we can see and observe HyTrack. And we removed some obvious non-tracking values, for example, some language codes or something. And we found that we didn't find any deployments of HyTrack in the wild, which is great. We just observed some candidates, but on closer inspection, they were just, let's call them fake applications. Applications that you launch on your phone, which just take you straight into a TVA. So what we observed there was like the regular web tracking on the web just ported to the Android application without being a real application. So we don't consider this to be HyTrack. But we did this no-touch analysis, right? And this is pretty scratching on the surface because we don't interact with the application. Maybe it just tries to track you if you have done something in the application. So we selected 95 applications and interacted with them for up to 15 minutes or until we decided that we have seen every feature. And we did the same process, again, searched the same way, filtered the values the same way, but again, we haven't found any instance of HyTrack in the wild, which is good. But dynamic analysis provides a lower bound. We can only measure things we actually can see, right? We don't see all the capabilities, all the possibilities. Maybe we didn't get the right applications. Maybe we didn't discover the right functionality in the applications. Or some other external factors. For example, the time or location. Maybe they just don't track people in Braunschweig, you don't never know. And of course, measurement pipelines that are dynamic are a bit tricky. So we did another study. In this one, we looked at the applications statically, which allows us to see all of the capabilities of the applications. And the idea was, hey, we can check if apps are using CTs and TVAs. We can check if they are using these custom unique URL schemes. And we can see if they register digital asset links. and we can search for patterns there. And we used AndroGuard, like this Python-based Android application reverse engineering tool, which is great. And that allowed us to search for calls and constants in the application. So we can search for CT and TVA usage. And we try to ignore code in Google libraries that are like compiled into the application. But this was not always possible because applications are usually minified or obfuscated in the Play Store. So we cannot just always search for strings. So this provides us with an upper bound. Previously, we established this lower bound of 0, and now we're trying to get an upper bound of possible HyTrack in the wild. So we found about 1,500 applications using custom tabs and about 190 applications using trusted web activity APIs. We found about 244 exactly digital asset links, and 190 applications use dynamic functions which allow them to add another digital asset link. And we found that about 2,000 applications have a custom unique URL scheme registered. And on further inspection, we found like certain clusters of these schemes. For example, if you're implementing this Facebook login with feature, it already uses these custom tabs as we have seen before. And they also do this back navigation step. So to take you back from the Facebook login screen into the application, they require you as an app developer to register this custom unique URL scheme to be able to take users back from their login screen web page to your application. So in total, about 20% or over 20% of apps have like technically the capabilities to do HyTrack right now. So we established this lower bound of 0% and this upper bound of 20%. And the truth is somewhere in between. And as a third and last study, we did a web measurement. And the idea here was, hey, we can just collect all the digital asset links from the website and search for certain patterns. So if we assume that we have this one tracking provider or a few, that they will all link to different applications, but different applications all link to the same website. So ad.com, for example. And to do this, we scraped the data from websites and got the Google Play metadata from Androzoo, like a data collection about Google Play Store. And from this Androzoo, we can get metadata about the developers of applications, because we want to search for applications by different developers linking to the same website. Only then we can assume that they are really independent and using the same tracking backend. So we did this, and we sourced our scraped domains from different known lists. So we got the top 500,000 websites from something called the Tranco list, and we got known web trackers from the Easy Privacy list. You might know this from your ad blocker, and known mobile tracking domains from the Exodus list. And we merged these lists and obtained about 560,000 different hosts. We scraped them all and collected about 15,000 valid digital asset links. And we then had a manual look at all of these, where more than 3 or exactly 3 developers are involved. These were 92 in total. And we've seen that all of these cases we found were pretty benign. For example, we had cases where different banking apps, which are from different developers according to the Google Play Store, are really powered by the same backend. So some white labeling going on there. So now we are in this weird situation where we have found this pretty powerful tracking attack. And I was pretty scared because this is pretty powerful, but it seems like nobody's doing this. So we are like at a pretty interesting point in time where we found this powerful thing, but nobody's doing it. So we should maybe do something against it before the tracking companies do it and invade our privacy. So let's discuss mitigations. And as I've teased previously, we use this pretty core feature, this shared browser state, to exchange tracking data. So we abuse like the core functionality, the core idea of custom tabs and TVAs to do the tracking. So it's pretty hard to mitigate HyTrack without breaking the initial promises of CTs and TVAs. And we call it like it's broken by design. And you can't really mitigate it without breaking functionalities. let's discuss some ideas, and I will show you how it breaks things. For example, one thing we came up with while brainstorming mitigations, we thought about, hey, we could limit the amount of websites that can link to one application or the amount of applications which can be linked to one website. So we have this one-to-one relation between applications or their CTs and websites. And this would totally work for, I have my application and my website. And I, as a developer, for example, don't want to re-implement every feature of my website in my application. For example, account information or settings or whatever. But this breaks this whole login with functionality. Like the promise of it's convenient that the user is already logged into some other web page and you can just open that web page. So this really doesn't work. We could also introduce some permission system. So like ask the user, hey, do you want that app X can use your data from website Y? But this would, of course, support every use case. But we think this is pretty unfair because we already have this pop-up fatigue. So users are like very used to just clicking yes, clicking accept, at least in EU countries. GDPR banners, cookie notices, yeah, please don't ignore me, just work, yes, 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 yes. So if we introduce another permission system, another banner, this won't fix the issue. And it really puts the burden upon the user for this thing that is, in my opinion, just broken. Of course, we disclosed this. So we first filed this as a bug with the Android tracking system, the Google Android tracking program. The Google Android disclosure system. And they said, yeah, okay, it's a Chrome bug, and moved it to the Chrome issue tracker. And then we reported it to Firefox as well, because they are also affected. And the Chrome team was like, yeah, won't fix intent behavior. I mean, this is true, because we abuse this core feature of this shared browser state between applications and between the default browser and the custom tab. But we abuse it to do tracking, and we don't think that's right. And the Firefox people are discussing mitigations, but that was like a year ago, and they have the similar problems as we just discussed. So it's a pretty difficult situation, because we have this new feature, or somewhat new feature, but it can be abused to track users, to invade our privacy. But we know that nobody is doing it, at least according to our data. So we think that, or I think that it's a pretty perfect time for us right now to act and to do something against it. Like as a community of security people, as privacy people, we should put pressure somehow on vendors to fix this issue and think about this. But until this issue is fixed somehow, systematically, what can I do to protect myself if somebody comes up with this and implements this? So you could resort as an individual for traffic blocking. If you just use some form of traffic blocking in your browser or in your net stack somewhere, and we know that somebody is using HyTrack as a community, we can put that instance of HyTrack on these blocking lists and just block the requests before they appear, before they do something. So, for example, if app A tries to track you and opens track on ad.com, the browser can just disable that request. And then the cookie will never be set. And if app B tries to track you, it will never send that cookie, and the tracking can never occur. But this requires the community to find instances of HyTrack and people to act and to use some form of ad blocking or privacy-based network blocking. My recommendation, for example, is using Firefox with the custom tabs, and then I can just install uBlock Origin, have some ad blocking going on, have some network blocking going on, and hopefully, if HyTrack ever pops up, that will end up on these known tracking lists. So my main takeaways for today are that with HyTrack, we're bringing like web tracking to Android. We can link users across applications and the web. And we think that custom tabs and TVAs are broken by design. We really abuse the core functionality, the core promise of custom tabs and trusted web activities to track users. And you should really use an ad blocker to protect yourself in the meantime until we can fix this issue somehow in the future. Thank you very much. If you do have any questions, please step up to the microphone.
Just really interesting research. And my question is around, are you rescanning apps periodically to see if this is going to get introduced or?
So we did these studies like summer of last year or something, and we redid the scans this summer, and so far we haven't found anything. But it's interesting because a while ago another research group found this other attack called local mass, and which was like a very involved tracking mechanism to track people similar across applications. So like the big tracking vendors are already doing these crazy technical steps to track you across applications. And now this one was discovered and patched, so maybe they will resort to the next tracking technique in the future. Maybe they will adopt HyTrack. Let's see.
Can the browser tell what app invoke the custom tab or the trusted web app? So
That's
it could isolate each app into kind of a non-shared space?
I think so, yeah. That was actually one of the mitigations the Firefox people were discussing. Like if they could separate the cookie jar by the application which is launching the custom tab. I'm not quite sure if that's technically possible yet, but I think it should be.
I guess other than a VPN, is it possible to create an app, desktop tracking app?
Is it possible? I guess you could replace your browser, yeah. But creating an application which somehow be able to hook into this IPC process which launches the CT or TVA. I'm not quite sure if applications can do that actually. With root maybe, but you could do like an on-device VPN, but that's again a network-based solution. I'm not quite sure. Interesting idea. Thank you.